Alright, I want to use this last video to just kind of bring it all together and try to separate when you use what and when you do certain procedures versus other times. Now, in this one, log base 5, you have one logarithm on the left, and there is not a logarithm on the right, so we can't use one-to-one property. This is an instance when we'll change it to exponential. This raised to this equals this. So we would get 5 to the third is equal to 8 minus 3x. And then, of course, do the algebra behind it. When I look at this one, I have a log here and a log here. So what I have to do is anytime I can condense it into one logarithm, and I can do that because they both have the same base. This one's a log base, a known base 10. So it allows me to condense it. And because it's addition, I can rewrite my arguments using multiplication. So I'm going to have x times 2x plus 1. Okay, once I've condensed this, now I look at it and I have one logarithm and a number over here. So it's going to now put us in this category where I have to take it from logarithmic to exponential. So I say this raised to this equals this. And so we would get 10 to the first power is equal to our argument. And then, of course, you would just do the algebra on it according to the notes. D, I see I have a log base 2 equals a log base 2 equals a log base 2. So all the way across my problem, I have logs. What I would like to do is if on my left-hand side, I can condense this side to be one logarithm. Log base 2. Because it's subtraction, I rewrite the two arguments using division. Now, once we have a log equals a log, we have our one-to-one property and we just set the arguments equal to each other. So I set this equal to this and solve according to the notes. So let's see which type E is. A log, a log, a log. I need to condense this side. Log base 10, since it's a plus, I'm going to rewrite using multiplication. So x times 3x minus 13. And then once we have the left-hand side simplified, I have a log is equal to a log. So that allows us to set our exponents equal to one another, our arguments, excuse me, the arguments equal to one another, and solve. And all I'm really doing is reminding you of when to do what. Okay, so previously, like I said with this one, when you have a single log on the left and not one on the right, you're going to change it to logarithmic form, from logarithmic to exponential form. When we have a log equals a log, we're going to condense and then set the arguments equal to one another. And I also wanted to make one other quick note on this. E right here, when we worked this out and we were trying to find factors that multiply to give us negative 30, and I set but add to give us, let's see, our factor was 3x squared minus 13x minus 10. We were trying to factor this out and we looked to see what would give us that, and I said, well, 3 times 10, and that wouldn't work. Well, we didn't check 15 and 2. Negative 15 and positive 2 would multiply to give us a negative 30 and would add to give us a negative 13. So we can continue this on to get the following factors. So we would put it over 3x, simplify right from the bottom up, and then this would give us x is equal to 5 and x is equal to negative 2/3, which is the same answers that we got when we tested them. So yes, that one will factor. We missed one of the factors in the previous video, but if all else fails, you can use the quadratic formula. Always try to factor first, but if not, use the quadratic formula and it'll work.